even if it's less than, we push it away from the mean, and
I
then
see.
later on we'll come and we'll actually change.
I see. That makes sense to me. When dealing with these pixels, though, you have to be a bit worried about overflowing them, going up. And Swift is really strict on overflowing. It'll actually crash at any point if you overflow any sort of integer or value. It'll just give up. So how? Yeah, there's a. So how we would do this? We would want to sort of get the red delta. And are we comparing it to the average pixel, or I guess the
No,
average
each of the
channel?
channels themselves. So we can say red delta is pixel dot red minus average red. We probably have to typecast pixel dot red.
Yes. You're getting the hang of this. Nice.
And same thing for the green and blue.
Yes, let's just do some copying here.
So now these deltas are essentially how far away we are, up or down, from the average. And we want to be twice as much away from this, from the average. So
yes, so we're actually just gonna we're just gonna set them back and do some math. So we basically want to add double the difference, plus 2 times the delta back onto the pixel.
right, except you should start with the average, right? Because
I see.
when
Yes.
we get these deltas, we know how far away we are, and when we set it back, we should start from the average and then decide how far from this average we want to be.
That makes perfect sense. And we're going to have to do some checking here. Okay, and here's where we have to do some sort of, first we're going to have to cast it. We actually have to cast it down to a inside 8-bit integer. And it's likely going to crash due to overflowing, but we shall be able to fix that.
Question: if we had to cast it when we declared the let, for example, the let deltas, what does it have to be cast again?
Yeah, here we casted it to an integer, and here it's back to a, here it's a 32-bit, and here it's back to a, sorry, maybe they're not inside, to an 8-bit integer. And maybe we don't have to do that. Oh, it is a 8-bit integer. Now it's complaining about something slightly weird. Oh, it's because average, right. Because this is also a 32 integer. So let's cast, we cast the whole thing instead.
Okay.
And this is where it might crash on us. And it probably already did. So how do we deal with the problem where if it might go out of bounds? Because as we said, pixels are 8 bits, which means they can only be from, each color channel is from 0 to 55. So an interesting way.
Yeah, so let's check if it's below 0 or above 255 and essentially cap it at those limits.
Right. Yeah, so I guess a sort of trick is we can use min and max to do this for us. So we want to make sure it's less than, it's less than 255, so we always take the minimum of it and 255, but we also want to make sure it's greater than 0, so we can take the maximum of that with 0.
And so let's look at that carefully. So when you take the min of 255 and let's say 256, the smaller one would prevail, and so you would get 255. So essentially it's capping at 255. But if it's negative 10 here, that min doesn't really help you. That's where the max comes in. So in the max, if you have negative 10 there, you take the max of that and 0, so then 0 would prevail. So this essentially is providing a capping on the bottom end at 0 and on the top end at 255.
Yeah, and it's a quite effective way of doing so. And I'm missing some parentheses. So now I should run. Hopefully. Please run. It is not running for some reason. So there we go. I finished again.
Okay, so is it crashing?
So we can look at the console, I guess. Oh, it is crashing. Let's see what the error message is. It is, we have a, here would be, so ignore these. These are because we're using a beta Xcode and they disappear every time. And it says we're doing something bad, and it doesn't really tell us what.
So the console is somewhere you go if something is crashing, you want to know what's going on.
Mm-hmm.
But in this case, it wasn't very helpful.
It wasn't. Maybe if we specified these as inside integers, does that even help? Probably not. So yeah, I'm not too sure what's going on here. Maybe we should bring this to a compiled project.
But we know what could be this. So if you're experiencing this, we know that if it overflows, as you said, it would cause crashing.
Mm-hmm.
So that's right now the most likely culprit that's causing this to crash.
Yes. It might also be here because so in this case, I think maybe it's already overflowing, so this cache might be crashing. Because if our value is overflowing and then we create an unsigned integer, 8-bit integer out of it, that may be enough to cause it to crash. So maybe if we move this outside. So we basically, once we get an integer and we after we cap it, then we assign it. That actually makes more sense. Oh yeah, there we go, live debugging. Yeah, so the issue there was because this is the value that potentially overflows, and it would overflow if we cast it to an integer. And so I'm trying to find a good way to say that the stupid me casted it first before we did the checking, which completely defeated the purpose because it was already casting and already crashing before we set it back. And there we go. Here's our output.
Yeah, so if you look at this image, it looks sharper. It has a higher contrast. The colors are more vibrant. And you've just created a contrast increasing filter.
Wow, it looks
now
a lot better.
Let's push that to the extreme. Let's make that 2 into a 10. And then what we'll see is maybe too much contrast in that case.
Yeah, let's see. I mean, this image looks really good. It looks like we're having a really good day. Where in reality, it's more of a grayish, gloomy day. All right, so it's doing its thing. And yeah, the more we do here, the slower it's going to be. But again, if this code was compiled and then ran, it really wouldn't be it would be instant.
So for compiling code and we'll get into that detail in the next course in this specialization.
Wow.
Okay, so here's an image, and you can see the contrast is really, it's too much contrast. You can't really make out some of the details very much.
Yeah, you've lost this whole part of the building.
Yeah. It's interesting, the contrast increase for the brighter areas perhaps doesn't look as bad as the darker areas. So if you look at this image, for example, some of the brighter areas, actually the contrast enhancement looks it's kind of a cool effect, but the darker areas are just now all black. So let's do a smart contrast increase.
Sure.
So that if the average color is bigger than the average overall image, we do essentially we do 10. But if it's darker, let's say we do 2. So the contrast increase on the lower side is less than the upper side.
Sounds good. So let's put this if about here, around here. Indent it properly. So the thing we're currently doing, we want to do it when it's brighter. So have a greater than.
But I think let's not put this in the if. Instead, we can change that 10. We can either set it to a 10 or a 2, depending on if the pixels...
Let's do that. What should we call that? That is sort of the modifier.
Sure.
And we'll set it to... I see what you mean. So we're going to move this code outside. And we're going to use modifier here instead.
Yeah.
Its execution is throwing me off. Whenever executes it.
Every time we change the code, it's the playground.
It's reloading.